as I mentioned. Also, there is a plugin. If English is not your first language, there is a plugin on Zoom that you can activate that will do closed captioning. Okay, next slide, please. All right, so again, I'm Aaron Poynton. Just a quick introduction of those who couldn't make it or might join late. The company was co-founded by me and my business partner, Michael Cardone III. Michael comes from a long history of the automotive space. We've also got on the left-hand side, Jonathan Doan, again, who's joining us, who's our chief of product management and joins us from Boston. Next slide, please. So who are we? A3 Global, we're a company that's really in the automotive space, but we're focused on where the automotive industry is going to be going rather than where it's been. So we're a mobility company that's being designed for the circular economy. And as you have noticed, there's a vehicle revolution that's taking place. And so we're at the forefront of that, trying to figure out how all of these EV batteries and hybrid batteries that are being pushed out on the road these days, how we can make them last longer, how we can repair them, how we can recondition them, and how we can reuse them so that they don't end up in landfills and they don't end up going to destructive recycling too early in their life. And you're here with us, joining us to figure out what business opportunities are available for us as we make this transition into the circular economy, which we'll talk about some ideas later on in today's presentation. But of all of these things that we do here, from sourcing to design to overhaul, we're going to be focusing today mostly on hybrid and electric transportation solutions around the processes, the technology, and the equipment that's used for reutilizing the batteries and reconditioning batteries and remanufacturing batteries. We'll get into some of the terminology in just a bit, because if you're not familiar with it, there is some nuances in the technology, in the language that's being used within the technology here. So next slide, please. And sorry for the distractions. We just have a bunch of people that are still coming in late. So I'm just going to give a brief introduction about what's happening in the marketplace as we see it, and then I'm going to hand it off to Jonathan, who's going to go into the details about the equipment and the processes and the technology. So again, as mentioned, although we're a fairly new company, we've only been in business for about 2 years. Our subsidiary companies, including Doan Systems and Hybrid Battery 911, have been in business for many years or decades before that. And most importantly, our team that we brought together comes from the automotive industry. We're led by Michael Cardone III, who is the third in a long generation of remanufacturing experts in his family, who had previously built Cardone Industries up to being one of the world's largest remanufacturers in the world, with about 6,000 employees headquartered out of the Philadelphia area. So Michael exited that business, him and his family exited Cardone Industries a few years ago, and that's where we came up with the idea to start A3 Global, to focus more on the future of transportation and mobility, and to position ourselves to be able to take advantage of the enormous opportunities that are coming in this vehicle revolution. Next slide. So as you may have noticed, there's a lot of things that are changing and happening in the marketplace. It never stays still. Sometimes the marketplace will get stuck somewhere for a few years or for a few decades before it goes through a big revolution. You can think about what happened with audiovisual, with the change from Blockbuster to Netflix, or what's happening with the banking industry to fintech. Well, we're seeing the same thing that's happening right now as well in the automotive space. And there's 4 key themes that are driving this, and that's connectivity, autonomous vehicles, the shared vehicle environment, and electrification. So we're going to drive down today on what's happening on the electrification market. So I think it's obvious if you pay attention to what's going on around you and you just look at the type of vehicles that are being driven today. You know, it was a little bit of hype in the beginning. There was a lot of people saying that they were going to do a lot of great things, but what we're seeing is that this is actually coming to fruition. Some of the hype has been just simply on the Super Bowl commercials for the past couple of years. where the vehicle manufacturers have been talking about what investments they're going to make in the EV space primarily, but the hybrid space as well. But here in 2023, we're starting to see the effects of these changes. And just earlier this quarter in 2023, in the beginning of the year, the Tesla Model Y took the #1 position for new car sales in the United States in the category of passenger cars, and it was #2 across all categories. And the company that took the position for the ranking of 2nd place through 5th place to round out the top 5 were all Toyota vehicles, and Toyota has about 50% of the market of hybrids. So clearly you can see that we've transitioned beyond sort of hype, and this is the reality. And projections are that by 2025, which is only a few years from now, that HEVs and EVs will account for close to 1/3 of all vehicle sales. And those projections continue to accelerate. Even if you look at customer sentiment and preferences, more than half of all respondents in a recent poll said that they are likely to buy an HEV or a EV on their next car purchase. And of course, some of this is driven by government incentives, but a lot of it is really driven by what's happening in the marketplace as the technology gets better and prices come down. Next slide, please. So if we're going to focus on the aftermarket, because many of the vehicles come with warranties from the manufacturers, we have to look back a couple of years and say, okay, which types of vehicles are now coming into the aftermarket? So, right now with our business, we're seeing mostly vehicles. Of course, we're seeing vehicles from before 2010, but we're seeing vehicles from 2010 to call it, 2018 that are really primed right now because for aftermarket third-party services, because they have either gotten damage to the vehicle that wasn't covered by warranty. They are outside of the manufacturers, typically, which is an 8-year warranty on the battery, or many of them also exceed the mileage.
To screen record on my laptop.
Just gonna ask you to mute. Thank you. So we're seeing these vehicles now come into the aftermarket, and obviously as more vehicles come on the road in the next couple of years, we're going to see more of these vehicles sort of stack up in the aftermarket. So that's really what we're focused on. So what this means is that in 2 years, if these projections are right, 1/3 of all new vehicle sales, those vehicles will have a battery in it, whether it's an EV or a hybrid, they will have a battery in it. And so that's really what we're focused on in our business. Next slide, please. So I'm going to take a pause there, and then now we're going to get into sort of the core of our technology and our processes, and I'm going to hand it off to Jonathan. So Jonathan, the floor is yours.
All right, thanks, Aaron. I appreciate the introduction. So yes, today we'll go over really how battery reconditioning, battery repair, the remanufacturing of batteries for hybrid vehicles works, focused on the nickel metal hydride batteries and modules, and looking at the different tools that we have to allow this procedure to occur for the reconditioning and the building of batteries. So starting off on this slide, you can see here that we have over 200 of our EVC battery reconditioning units been deployed worldwide in about 18 countries, actually. The majority of these units are in the US, over half of them, but as you can see, this is pretty significant, especially because this instrument's been around for a handful of years. And we'll start here with going over a little bit about the EVC30 itself, and then going into the actual battery reconditioning. So what this EVC30 unit does, it utilizes a simple to use EV charge software, which includes the reconditioning recipes for all the different type of hybrid vehicle battery types. This instrument, the software allows you to export all of the module state of health summaries, and is a piece of technology that is pretty advanced, has very high speed data acquisition. It also includes a pack builder software package that allows you to track your module inventory, and will select and build battery packs based on your modules and sequence them. So all of this is based on the reconditioning and the diagnostics that are received from the modules. And that includes all of these module state of health parameters here. Okay, so the amp hour capacity, watt hour energy, voltage, and internal resistance. Those are all key concepts and parameters for determining the state of health of your modules. This is kind of a partial list of the list of nickel metal hydride batteries that our instrument can process. As you can see, most of these are the Toyotas that are hybrids, some Lexus hybrids, along with GM, Cadillac, Honda, Ford, Nissan. There are a number of other vehicles and other battery types that our instrument can recondition, especially internationally. There's a lot of other companies and other vehicles that are not included on this list. This is mainly based on the US market. So if you have other vehicle types that you are concerned about or have questions about, please let us know. And actually, I just also want to note that there's a chat feature in this webinar. So if you have questions and want to place them in the chat, feel free to do that, and we will address them during our breaks every couple slides or so. Here, so these are kind of pictures and depictions and specs of a couple of the nickel metal hydride modules that our instrument, the EVC, can process. You have the typical Toyota Prius prismatic, as you can see here, which are 7.2 volts, 6.5 amp hour, and they contain 6 nickel metal hydride cells in them. So this module, you see here, 1, 2, 3, 4, 5, 6 cells. All right. A little bigger if we're moving forward. You have your Toyota Highlander. So it is similar in amp hour rating. However, the voltage is higher due to the higher number of cells in it. And if you can count, there are 8 of them in these. And these are both prismatic. All 3 up top are prismatic. And that refers to its shape that's kind of like a square. We also have some secondary aftermarket modules that are available, and they can also be reconditioned, but they are very similar in shape and profile to the original Toyota prismatics. The next type is also the cylindrical that we have. So we have the Ford OEM, and these are found at the Ford Escape. There's actually 50 of them in the Ford Escape, and these only have 5 cells, so a lower voltage. That's why you can see that it is 6 volts. Each of the cells is 1.2 volts. Okay, so that's how you have the 7.2 for the 6 cells up here and 6 volts for the 5 cells. We also have the cylindrical modules from Honda that are similar in specs to the Toyota Prius. And we also have these other aftermarket secondary modules that have 12 cells in them. So if you can picture it, these are 3 cylinders with 4 cells in each. Okay, they look kind of like really big D size batteries, and each of these takes up the space and replace kind of the 6 cell modules. So moving forward, if you have, in this case, we'll talk about these modules in terms of a Toyota Prius pack here. So with the individual module, if you have 20 of them together and put in series, that forms what we refer to as a core or pack, okay? And this set of modules is 202 volts because all of these modules are in series. So the voltage is multiplied, the 7.2 volts times 28. And with those 28, if you put them inside the enclosure, we then refer to that as a full battery. Okay. So what happens within the vehicle that causes these modules to age, the battery to go bad? So during normal operation of your vehicle, your hybrid vehicle, the vehicle only affects the battery in a way that allows it to have a shallow depth of discharge. So what does that mean? It means that when you're driving your Toyota Prius or Camry hybrid, it's only using 10% of the battery capacity at any time. Normally, your battery capacity sits at about 80 or 70% and only goes down to about 60, and then we'll go back up. And that's because as you're constantly accelerating, that discharges the battery a little bit, but then your combustion engine kicks in. And then once you brake, the regenerative braking allows your battery to charge back up a little bit. So you're kind of only going up and down. It's very, what we refer to as a shallow depth of discharge, okay? And what that means is this large fraction, all of this down here, imagine this is a diagram of your battery, a large fraction of that active material goes unused. Okay, so you're really only using part of the battery at any time when you're constantly accelerating and braking. And this is for a hybrid. So because that large fraction of the active material is unused, you start to get, over time, reversible structural changes. This is mainly physical and refers to the grain boundaries that form in the active material and crystallites that form, okay? Eventually, that battery really only remembers the lower capacity. So all of this is kind of unused, and that's what's referred to as the memory effect. So the battery just remembers the lower capacity. It doesn't remember that it has all this unused material down here. What nickel metal hydride battery reconditioning does is it restores that lost amp hour capacity by repeated deep charge discharge cycles down to a low voltage. Okay, so if you kind of discharge and charge your batteries down to low voltage, it'll kind of break down all of those grain boundaries, crystallites, restoring all of that lost amp hour capacity, and your battery will function with, or not necessarily as new, but it will recover a lot of that lost capacity. So you can get, instead of 6.5 amp hour, your battery could come in at about 2 or 3 amp hour, but after reconditioning, it can gain a few more amp hour and get it back up to 5, 5.5, possibly even 6. Okay, so it really depends on the state of the module and if there are any other types of damage to it in terms of heat and other sources that we'll discuss later. But once it is reconditioned, the next step is the diagnostic. So the instrument will give you all those state of health parameters that we discussed earlier, and they're all measured at the original OEM standards, okay? We then have a last cycle that charges the battery back up to an intermediate state of charge. So why is it only going back up to an intermediate state of charge and not all the way back up to 100%? And that's because when you install your battery into a vehicle, let's say your customer drives off the lot and brakes really, really hard, and that can overcharge the battery, causing damage. So overcharging batteries is a big way to damage your battery. So you do not want to overcharge. That's why when we install, our finishing cycle ends up at an intermediate state of charge, okay? But typically between 80 to 60%. An example here of the data shows what it looks like before and after reconditioning. So on the left, you can see the before, where we have very uneven discharge profiles. And this is of a Toyota Prius pack, so that's 28 modules. You can see the discharge profiles. Some of these modules end early and don't go all the way to the full hour. And you have a lot of not only uneven discharge profiles, but also high internal resistances. Okay. After reconditioning, after those cycles of discharge down to low voltages, this battery pack is now very balanced, very even, and not only balanced even, but very high in amp hour capacity. And you can see below, we have brought down the internal resistances. Okay. So this is what an example of the reconditioning data will look like. And now I will kind of explain what this total system encompasses. This slide here shows what the battery workflow system looks like. On the left, we'll kind of start here with what we call the battery cores. Okay, so battery cores, that is used or battery packs that come directly from vehicles that either have some faulty modules or basically need to be processed. Okay, so once you receive those battery cores, you will then put them on the EVC30 and recondition the modules. Okay, once you're done reconditioning your modules, they will then be moved to your module inventory. Okay, and you separate all of the modules out. And the battery pack builder, the special thing about the battery pack builder is it will look at your inventory and choose modules that will form a balanced pack. And it will also sequence those modules for you within that pack. Okay, so it'll tell you these 28 modules, and this is how you arrange them in sequence when building your battery pack. From there, once you build your battery pack, the next step is to power test it. Okay, and the EVD40 is a power testing unit, and we developed it after the EVC30 based on input from our customers at the time. This was developed about 3 years ago, and what it does, it's basically a vehicle simulator. So it will allow you to discharge and discharge your modules at a very high current and high power, similar to the currents and power found in the vehicle. And what that does is it allows you to see if there's any modules that kind of make it through the process, look good at lower currents. However, when it's submitted to 50 amps, 60 amps, that module may fail. Okay, so the power test will allow you to identify any of those modules before you build the complete battery. And if any of those modules have issues, you can then go back to your module inventory, replace that module, power test again, and then build your complete battery. Okay. This here is a diagram of what the front of an EVC unit looks like. You have your power. We have an emergency shutoff, which is known as the battery connect disconnect in case you need to stop the process while it's running. All of our instruments connect to a laptop computer, and that EV Charge software on the computer provides real-time individual module data. We have our charge discharge indicators here. So if you are, let's say, across the room or wanting to just quickly look at the front of the instrument to find out if it's what step it's on, if it's either charge or discharge, one of these lights will be lit. We have 30 channels, so you can recondition up to 30 modules at a time, and all of this is in parallel. Okay, that's very important, that each module is connected individually to a channel, and we control that module in terms of the current and the voltage separately. We also have down below, our instrument runs on 220 volts, okay? And we have 2 fuses down below just in case there's any issues.
Jonathan, there's a question in the chat.
Yes, okay, great. Let me look at these questions. So what criteria are used to build pack match modules? So yes, that's a good question. When we our battery pack builder uses a special custom like algorithm that we look at that takes into account the amp hour capacity, the voltage, the resistance, and the watt hour energy. So building a pack, you have to look at all four. Our software looks at all four and will choose the best modules to build your pack out of your inventory. So those are the four criteria. And what I can really say is you want them to be close in terms of their numbers for that criteria. And the next question is, do you actually apply a full 50 amp load to the individual modules when load testing? So that's a good question. This has to do with the EVD, the power tester. No, when the modules are load tested, that it occurs, you run that step when all of the modules are put together in series already. But each module does undergo the 50 amp current, that 50 amp discharge, while monitoring the voltage. So even though they're connected all together in series, the modules, the voltages are individually monitored. Okay, and that occurs with the EVD40. Okay, I hope that answers those questions. That's good though. Please, if you have any other questions, please put them in the chat and we will address them. So the next question, this slide here is kind of a reminder that you want to keep your pack cool under reconditioning. Okay, so we include a cooling box as well as our cooling box fan. Okay, and when you clamp that pack together, all of the modules together and connect it to the EBC30, you want to make sure that it is clamped with the two end plates, we call them, and that air is flowing in between each module. So if you look here, you should feel when you have the fan on, you should feel air flowing in between the modules, and that will keep the modules cool, because during the charge process and sometimes during the discharge too, you will get modules that heat up and can start swelling. So you want to make sure two things: clamped and cooling. Okay. All right, looks like we have some more questions before we move on.
Yes,
What
one more.
point is a module considered not serviceable? Yeah, so that's a good question. Generally we try to keep, so let's say there are other types of failure modes within modules besides what we call the memory effect, right? So the memory effect is reversible, meaning that we can fix that. However, there could be leaking from the terminals. So at these terminal ends, sometimes you get a white residue, and that means that your module is leaking the fluid, the liquid inside the electrolyte. And it can also leak from the bottom. You could also have some structural damage, heat damage, and that will lower your module capacity as well as increase the module internal resistance. So generally we try to keep after reconditioning, you want your module to be above at least 3 amp hour. Okay, so any modules below 3 amp hour, that's when you either want to repurpose them for another application, like not use them in vehicles, or you could also then send them to a recycler or use them for some other purpose. But 3 amp hour is about our cutoff, and that really depends on where the module is found, what part of the world you're in, and all of those different factors will determine the quality and parameters of your core. Okay, next question is, what's the lifespan of a reconditioned pack? We do have modules that have been put into a pack, and that pack has lasted over about 4 years now. So typically I would say a pack, depending, it really depends on the quality of your core. So what type of modules you get out of it for the diagnostics. And it depends on not only the average, let's say, of your amp hour capacity, but also how balanced those modules are with each other. Okay, so the lifespan of a pack can range from, let's say, a number of years. So we've had some packs that last 4 years. But if your pack is not very balanced and you are using something like 3.5 amp hour modules, that pack could last 6 months to a year. But you know what that quality is, so you would maybe charge less for that pack, right? Because you know it's only going to be it's a lower quality pack with lower quality modules. If the module is connected in series when load testing, how can you be monitoring individual module data? We have a specialized harness I'll show later that has voltage sensors on each of the individual modules, as well as connected them all in series for the power and the current. Okay, so we do have a special harness for the load testing. Supporting EV. So, okay, the next question here is about electric vehicle batteries. We are currently we're in development of our technology for electric vehicle batteries now. Stay tuned for updates, and we're still doing research and still doing development on that process and how to remanufacture electric vehicle batteries. What do you use failed modules for? Next question. So you can either send your failed modules to a recycler or sell your failed modules to a recycler if you have a large number. You can also, there are places that will buy your failed modules, but you can also build, we have a couple projects where we use modules that are not strong enough to be used in a vehicle. However, we can repurpose them for energy storage. And we've done a couple of those projects where we use the modules to, run and store power from solar panels. Okay. And yes, we do have, we are recording this webinar. So I'll speak with Mateo and Aaron after and see if we can make the recorded version for you available. Lithium-ion batteries. Oh, Aaron, thank you. Yes, that is true. For the lithium-ion batteries, they are not just in electric vehicles, but also some newer hybrids, such as the plug-in hybrids. Okay, those also use a lithium-ion battery. So both, I would say now, looking at the state of the market, both lithium-ion batteries, which is what our new, which is what we're doing research into now, both lithium-ion batteries and the current nickel monohydride batteries are still being used. So Toyota has their Toyota Sienna, the new 2023 model year. It is all hybrid. So every single one of those models is hybrid, and they all use nickel monohydride modules similar to these. So even though we know that the future is leading towards EV, and we are addressing that with our research and development, nickel monohydride modules are still being used. I just want to point that out. There's a question here. 3 amp hour modules sounds extraordinarily low capacity. I rejected below 5 amp hour capacity. How can you get a pack to balance with such outlier modules? So if you build a pack, let's say with 3.5 amp hour modules, it depends on all the other parameters, and the pack builder will sort through that and make sure that they are very close together and also sequence in the correct order. We do have packs that are low, let's say 3 amp hours or so, that have lasted within vehicles for up to a year. Okay. Okay, great. Please keep adding questions if you have them, and we will move forward with the next slide. So some additional notes. Our EVC, it includes a laptop with the software installed. We also have a QR code reader that's important to keep track of your modules, not only within your shop, but also once you install them. And we also include an adjustable torque drill. And that's important because these terminals, when you are connecting the nuts onto the ends here, there is a maximum of 50 inch-pounds. Okay, that's the maximum torque for the cable connections. If you go any higher, you can risk damaging. And early on, we did see using stronger torque, it did damage the ends and ended up pulling them off. Okay. So you want to make sure that you use a maximum torque of 50 inch-pounds. I also want to note that you want to make sure that you clean the bus bar connections, and that's possible a couple ways. You can either use CLR, which you rub onto the bus bars. It's kind of a paste, and then you can clean it off. You can use a vinegar bath, wire brush, but I just want to emphasize that these bus bars, these copper bus bars, must be cleaned because any residue will increase the internal resistance and hinder the performance of the battery modules. One other recommendation I have is using phenolphthalein, which is a acid-base indicator, and you can purchase that on Amazon or other supply stores. And it is a liquid that is clear, but when you dilute it and spray it onto these modules, you can detect any leaks. And that's because in the presence of a basic solution, it turns pink. So you will be able to see if you spray it on the modules and you see pink, the liquid turns pink, that means that that module has been leaking or the modules around it has been leaking. Okay. We have this next slide here kind of shows, I just want to emphasize here the importance of the other parts of the battery. Okay, so the module is, let's say, the most important part of the battery, right? Those are the 28 modules with 34 in a Camry. And if you recondition correctly, pair them up correctly, and make a very balanced pack. Don't forget, you also have the cooling fan. You have the ECU. You have the connectors. You have the bus bars. All of those other components need to be tested, or at least make sure that they are clean and that they work properly before putting them together. Because a lot of times you might have great modules, build a battery, and you don't really know what's wrong with it if it comes back. However, another component could be the cause of the problem. Okay. Let's see. It looks like we have some more questions. Okay. Assuming one follows the reconditioning parameters and using cells matching parameters, what percentage catch fire in vehicles? Are there reports of cars catching fires more to do with EV and plug-in hybrids versus combustion engine hybrid batteries like Gen 2 Prius? Yes. So that's a good question. With these nickel metal hydride modules, with the hybrid vehicles that we're referring to today, they are not flammable. Okay, so these nickel metal hydride modules here, the electrolyte or the liquid inside of them, it's water-based. So they are not, it's not an organic substance that's flammable, such as lithium-ion batteries. Okay, so all of those fires that you hear in the news and those reports, that is for lithium-ion. Okay, so that's another piece or danger that we are looking into when we're developing our technology for that, and that's research development that's to come. However, with these, just to emphasize, the nickel metal hydride modules are not flammable and they will not catch fire. Okay. So what percentage? It's 0 with these, they do not. Okay, and the next question is, do you not recommend nickel plated bus bars? I have done both cleaning and with nickel, no discernible difference. Yes, that is also a possibility. We have had that. Yeah, you can also nickel or zinc plate these bus bars. You can see here that that's why they are this color. But most of the time, either you can get them stamped. There's a couple of different ways, but I was just showing that, yeah, you can clean it or you can get it sent to a processor that will clean them and plate them for you. Okay. And the nice thing about plating it is that it will reduce future residue and formation on it, okay, versus the copper. Okay, great questions, everybody. Keep them coming if you have any more. This slide here shows that we have our kind of software system, our software packages. Okay, we have 3 main softwares: the EV Charge, which runs our instrument. We have the Battery Pack Builder, which tracks your module inventory, allows you to look at all the parameters, and will select your module set and pair them for you. Okay. And then we also have the EVD40, and that software allows you to run the power test and look at the discharge, the high power discharge curves. Okay. So I'll kind of go into these a little bit more with each of the next slides. Here you can see that we have our reconditioning data, and it will convert that to a summary file. And with your summary file, you will then import it into our battery pack builder. Okay, so that battery pack builder will take all your summary files, will automatically remove what we consider poor modules that don't meet the standards that are likely to fail within the vehicle. It will select and then sequence that set of modules. Okay, and when it selects, in this case, this is for Camry, so it's 34 modules. It will then give you the exact order, and then you will just install those blocks sequentially. Okay, once you install those blocks sequentially, if you have an EVD40, you can then run the power test. All right, so our harness, and you'll see it in the next couple slides I'll show, will monitor each of the modules, each of the module voltages under high current pack discharge. Okay, so that's about 45 amps, could be 50, it depends on the size of the pack. Our large, let's say, I think the Cadillac Escalade has 40 modules, and that current for those that power test is above 50 amps. Okay, and once you do the power tests, you can then charge the module back up, charge the whole module set or pack back up using the built-in power supply. Okay, and here's an example of what it would look like with the power test. So here we have 34 module voltages. This is a quick 30-second test, and you can see all of the modules, they drop down because that's what your voltages will do when it's under load. However, you have these 2 modules here, the pink and the green, and they drop down, you know, past 6 volts. This one gets to, lower than 6 volts after 30 seconds. And this one drops down to about 5.4 volts, okay? So these 2 modules fall out from the rest of the pack, and they would be modules that need to be replaced with input from your pack builder, okay? And here is what our universal harness looks like for the EVD40. You have your positive, let's look down here. So you have your positive high voltage and your negative high voltage, along with all of these different voltage sensing circuits. Okay, so once you put this harness on, and it fits on all 4 of these types, you can have 20, 28, 34, 40. number of modules. And once it runs, it will give you all the data from your power test, and it will also allow you to charge the modules back up after the power test. Here are a couple of the specs. And again, I just want to emphasize that this EVD40, the power test, was designed to save time and labor so that you don't have to test drive. Because before we had this instrument available, most builders would put the pack together, put it in a car, and have to test drive. So using our EVD40, you can save time and labor. You don't have to install it in a vehicle, test drive it, and then bring it back out. If there's a bad module, you can replace it directly. So this process for test driving versus power test, will take you 15 minutes versus over an hour if you can do it quickly. Okay, here. So this again is our workflow system. Here, I'll just take a minute and go over it. It is a little more detailed than the previous workflow I showed, but starting with your core inventory. Here it shows that you want to remove the enclosure, that's the outside, take your cores, leak test them, and then put them on the EVC30. Okay. From there, you'll recondition your modules depending on your core supply, the quality. It could reject up to 35% of the modules. Okay, so that means that those 35%, so out of that 28, you might have, let's say about 7 of them or so are not fit for building a pack to put in a vehicle. Once you have those reconditioned modules with all their data, put them in the module inventory, use Pack Builder to build a set, and then power test. Okay, if that passes, you will then take those modules, combine it with a refurbished or replaced enclosures and other components to build your battery pack inventory. Once you have your battery pack inventory, that can then be installed into your vehicle, and then you'll receive that vehicle's current core. So it's kind of circular. You get the core return and process and go into your core inventory. Okay, so this is kind of the workflow system. And you can see here, I have the next slide, kind of shows one of our facilities in Phoenixville, Pennsylvania, near Philadelphia, and how the packs come in, and then are processed, the cores come in, processed, and then the packs are built, modules reconditioned, and then it goes out. So here we have 6 EVC30 reconditioners, along with an EVD for power testing, custom designed workstations. Again, this is for a full factory, and a lot of our current owners, kind of start small and they have like 1 instrument and start doing a few packs a week, and then eventually grow into a larger operation. So what does this mean if you start with just like 1 EVC30? This slide here kind of shows what your ROI would be on a single EVC30 unit, and this is assuming that you are a couple of assumptions, right? You are working the 21 days a month, and that considers just the weekdays, and you might have 1 running over a weekend. You can then process 630 modules. Okay, so within that month, there's 630 modules. Let's assume what we said before, that return rate is only 65%. So you end up with 409 modules. From this 409 modules, if you build packs with them, the total Prius packs, which are 28 modules per, you get about 14 of those Prius packs, and assume your margin on each pack is about $700. That will yield $9,800 per month of your margin. So the EVC30, I believe the list price right now is about $36,000, and if you divide by 9,800, it's about 3.67 months. So a full-time EVC30, if you were running it, just on the weekdays, full-time, and have the starting inventory you need, you can fully pay that off in less than 4 months. Okay. So any questions there. We have we'll have a little bit of time. There's just the last slide here for questions after, but I just want to make sure that all of you are aware of our websites, nuvant.com and a3global.com. We have a resource center. We can find manuals, data sheets, our informational blog. We have some instructional videos on YouTube. And if you have trouble finding cores, because that's kind of coming up now, please let us know. Mateo can contact you and work with you on that. And I see that we have one question here on the meeting chat. So how do you clean the 8mm nuts? You would clean the nuts kind of the same way. You can either put them in a vinegar bath, some type of solution to kind of clean them off, and use a tumbler, or just old school elbow grease and kind of clean them off with a wire brush. Okay. 8mm nuts. Yeah, so please let us know if you have any questions. I'm opening the floor to that. And if you have any other questions afterward, please email me or call us here.
Great, Jonathan, thank you so much. We have one or two more questions that might come in, but let me just say a few concluding comments here. So first of all, thank you everyone for joining. If you're a current customer, hopefully this was helpful for you as you use your EVC and your EVD in your operations. If you're a prospective customer, please reach out to Mateo. We're happy to give you information about how we can get you started with your own reconditioning, remanufacturing business. We also do have flexible payment plans as well. And then finally, if this is something that you're interested in, but you don't want to take the time to set up your own operations, or you don't have the capital to do it, please also reach out to Mateo, because we just started a program called the Green Light Hybrid Program, which will allow you to basically be the front end and sell the batteries, and we will provide you with reconditioned and remanufactured batteries that either we could install for your customer if you're in the United States, or if you want to do the installation yourself, you could do that too. So you can participate in the EV revolution without making the capital investments by partnering with us. So I'll conclude here. Thank you so much, Jonathan. If you want to take us out here with any final questions.
Yes, thanks, Aaron. I see a question here. For new businesses with 35% of modules toast, supplying 3 to 4 old batteries to make one pack. So do we sell individual modules? We do not, but as Aaron said, we can contact Mateo about the Greenlight program. But I just want to clarify one thing here. If 35% of your modules are bad, let's say you have 10 cores, you would be able to produce, say, 6 or 7 packs. So you wouldn't need necessarily 3 to 4 old batteries. And it really all depends on your core source, your module core quality. Okay, so sometimes you might get packs in where only one of the 28 are bad, and then the rest are usable. But at 34 is kind of 35% is kind of an estimate. But yeah, we'll please contact Mateo on that purpose for the green light. Okay, any other questions? All right, thanks again, everyone, for attending this webinar, and please reach out if any questions arise later on.
Mateo, if you could just stick your email in the chat box if you haven't.
Yeah, I'm actually doing it right now, so everybody has my contacts, which is also in the email that they receive. But here it is.
I will say one final thing. I mean, if you are in need of modules or cores to feed your business, although we typically don't sell them directly, we might be able to still help you out either on an interim basis to get started, or to direct you maybe to one of our core suppliers. So let us know what you need. We'll do the best we can to help you. Okay, everybody, have a fantastic day. Thank you for joining.
Thank you very much.
Bye.